In this lesson, we're going to introduce this idea of linear approximation. So we're going to try to use some calc to see if we can come up with a square root of 1.1 and a square root of 0.1. We're going to get a rough idea of what these values are, and then we're going to talk about, or is our value a little bit bigger, a little bit smaller than what the actual value is. So here's our formula that we're going to use for this. And it actually comes from your point slope formula. So you're going to have a slope times x minus a, which is a slope times x minus x1. And then this y1 just gets shifted over to the other side, and that's that value, right? So this a value that we're going to be focusing on is if we were going to be estimating the square root of 1.1, we need a value that we can plug it into a square root type of equation that's going to work nicely. So this is us finding like a perfect square that's as close as we can get to this. And we'll show you kind of that what happens if we're not picking a value, right? Like there's kind of a, how far off are we compared to finding a value that's a little bit better? So for us, we're going to be using the linear approximation to finding the square root of 1.1. So our equation that we're going to focus on, so then we can do a derivative and find a slope is going to be the square root of x. And then our nice value is going to be at, actually that's going to be our a value is going to be 1, right? So our a value is going to be our nice number. So some stuff that we need in order to do this is we need a slope equation. And so our equation is the square root of x. So if we're going to do a derivative of it, let's go ahead and make it x to the 1/2. Let's do the derivative of it, which is going to be 1/2 x to a negative 1/2. Then if we clean that up, we're looking at a slope equation of 1/2 square root x. All right, so that's our slope equation. So let's do a little bit of math here. We are trying to estimate 1.1, and that's actually our x value that we're going to be using. Let me rewrite that. Our x value is going to be the 1.1. Right, so that is what we're going to be using to plug into this formula. Our nice value that we're going to plug in to get a nice y value, to get a nice slope, is going to be our close value to 1.1 that we can actually square root. So the math is we are going to estimate this square root of 1.1 is going to be the square. We're going to be plugging in our nice value into our formula. And so we're going to have the square root of 1 plus, we're going to find the slope at 1. So if we did the slope at 1, we would have 1/2 times the square root of 1, which is 1/2. So then that is 1/2 times the value that we're looking for minus our nice value. All right, so we're going to get a pretty close, reasonable value to what the actual square root of 1.1 is from this. And we'll talk about, are we over, are we under? We'll get a little bit of idea. So square root of 1 is 1 plus 1/2. 1.1 minus 1 is 0.1, which is 1 plus half of this is going to be 0.05, which is 1.05. So our estimate of square root of 1.1, we're estimating it to be 1.05. Now the actual square root of 1 is 1.0488, and on and on and on and on. So we're going to talk about, like, we're a little bit high, right? But it's pretty close, but we're a little bit higher. And there was a way for us to actually know that that was going to happen, that we were going to be off a little bit. Like we're going to be off a little bit for sure, but that we were going to be a little bit high versus a little bit low. And that actually has to do with the concavity. So we are talking about a square root graph. Well, let's come back and just in general. Concavity is if you have a shape of a graph that what we're actually doing is kind of creating a tangent line. And so we're creating this equation that we're creating right here is this, and we're plugging in a particular value to it. So what we found was the slope at this particular point, and then we took a point a little bit further away. And since it's concave down, what we're doing is when we plug in that value, we're finding a point on this tangent line, which is going to be a little bit higher. So our value is a little bit higher because of the concavity that we got going on. So if you're concave down and you plug in a value, you're going to be a little bit higher than what the real value is. If you're concave up and you're plugging in, you're getting the point on the tangent line, which is going to be a little bit lower than what the actual value is. So concave down, where it's going to give us an overestimate because we're getting a point on the tangent line. And then concave up is going to be a little bit under because, again, we're getting a point on the tangent line. All right, so we were here, right? We found this slope here. Here's our line. And if we plugged in 1.1, we found this value, which is 1.05, and the actual value is a little bit less, right? But we're pretty close, and the closer you get to that actual point, or the closer we can get that point to this actual point, is going to make it more and more accurate. So if we do the next one, and we're looking at the square root of 0.1, but we use this same value, which isn't as close. So we would have our x value would be a 0.1. Our close, nice value is going to be 1, which really is probably not the closest. But let's just kind of see what happens. So if we follow this formula, 0.1, we are going to be getting our y value, which is exactly, we're still plugging in a 1 into this equation. So square root of 1 plus the slope at that point, which we found to be a half. And then our x value is 0.1 minus 1. So here's what we're getting. We're getting a 1 plus 1/2 of 0.1 minus 1 is going to give us a negative 0.9. And if we take half of that, we're getting a 1 minus 0.45. And if we do that math, we're getting our estimate at 0.55. So we're saying that the square root of 0.1 is about 0.55. The actual on that is 0.316, which is definitely further off than what we were here, right? And that has to do with that this is our point, that when we're plugging it into this line, we're plugging into this tangent line, we're getting a value here when the actual value is here. So the further away we are from this nice value that we're using, the more inaccurate we're going to be. And because of the concavity, we're still getting an overestimate, just like we assume we should, right? If we have a concave down at that section, we're going to get an overestimate. So no matter what, we're going to be at a higher point than the actual curve. All right, so that was a little bit of an introduction to a linear approximation. We'll do a couple more examples in another video.